Hi everyone. So let us solve today's problem of the day, that is sum of XOR of all pairs. Okay. So let us go through the problem. Given an array of n integer, find the sum of XOR of all pair of numbers in the array. In other words, select all possible pairs of I and j from 0 to n minus 1 such that I is less than j, and determine sum of all array of I XOR array of j, right? So basically, what the question is stating is that we have an array of integers, and we need to select some certain pairs such that I is less than j, and we need to return the sum of all the XOR of these pairs, right? For example, if we have 7, 3, 5 as input, so what are the possible pairs that we can get in here is 7, 3, 7, 5, and 3, 5, right? So if we XOR these values, we are getting 6, 4, and 2. And at the end, we have to sum all these up, right? So we need to return this sum. So one of the brute force approach could be that we run two loops, right? So this is the brute force approach that we can apply in here. So we can take a sum variable and we can run two loops, I and j, and every time through iterating the array I can just add the XOR of both the pairs, right? So the time complexity here would be O of n square, but it has been mentioned that we need a O of n solution, right? So we need to think something of bit manipulation. So I hope you all are clear that an integer is represented in the form of 32-bit binary format, right? And its indexing starts from the right hand side, such as to, and the if that ith bit is set, that means it is contributing 2 power I to our answer. For example, 0th bit is contributing 2 power 0, then 2 power 1, and 2 power 2, and so on. Okay. So how can we solve this problem? Let us go through this example, right? We have 7, 3, 5 as input. If we represent these numbers in their binary formats, we will get it as 0, 1, 1, 1, and then simultaneously all these numbers, right? So what are the pairs that we can get? We can get the pairs as 7 XOR 3, 7 XOR 5, and 3 XOR 5. So if we look at these pairs, what we can see is that uh, if I can represent the sum that we are getting it as 12, if we add all these numbers, we will get it as 12, right? So are we getting that 12 is if I represent it in an another way. So let us see the 0th index, right? So 0th bit, how many bits are contributing from the 0th index? 0, right? There are no set bits in the 0th bit. So what we can do is 0 into 2 power 0, right? If we look at the first or the first index bit, so there are two bits which are contributing to the first index, so we can write 2 into 2 power 1, right? So in the third or the second bit, what we can see is there are two set bits, so there are two elements which are contributing to my XOR. So again I can write 2 into 2 power 2. So what is this 2 power 2 is that I already said that ith bit is contributing 2 power I to my answer, right? And again on the fourth bit, what we can see that there are zero set bits, so we can write 0 into 2 power 3. So we'll get the answer as 12. That is the correct answer, right? We get it as 12, right? So this is what the approach will look like. But to generate these pairs, what we can do is every time, first of all, for every index, or we know that there are an integer can be represented as a 32-bit integer, right? So we can go to every ith bit and check the number of bits which are set and the number of bits which are not set, right? And if we multiply both of them, we will get the number of pairs which are contributing to my sum, right? We'll get these pairs. So that is what we'll be doing in our solution, in our optimized solution. That is, we'll be going at every bit from 0 to 32. And at every bit, what we'll be checking is that the number of elements inside my array in which that ith bit is set and that ith bit is not set, right? And I will multiply those two to get this number, that is to get my number of pairs which are contributing to my sum. And to which I can just multiply 2 power I, that is the sum which they are contributing. Okay, so we'll go through the code once. Okay, so this is the code, guys. We take a sum, right? And we run a loop from 0 to 31. So these are the bits that we are iterating through. At every bit, I will take two variables, that is 1 and 0. Each of them will have the count of number of ones or set bits and unset bit at that particular index. I will go through for every bit, I will go through all the numbers and check if their ith bit is set or unset, right? At the end, what I can do is I can take the product as 1 into 0. That means I'm taking the number of pairs that are generated with that with that number, and I can just add. So this one left shift I is 2 power I, okay, and I can multiply it with 2 power y, 2 power I, with the same thing which I am performing over here, and we will return the sum. So I hope you're clear with this approach. Thank you.